Helfrich, K7XTN, received his amateur license in 2017 when he and his spouse began working on disaster preparedness with neighbors. He's an enthusiastic digital ham and serves as one of the regular net control operators with the Puget Sound Digital Hams Net, which is at psdhn.org. And he's primarily active on VHF and UHF. He's a member of Seattle Auxiliary Communication Service and the Western Washington Medical Services team. So, Christian, we are really excited for your presentation today, and welcome to Com Academy 22.
Fantastic. Thanks so much, Tim. Thanks so much, Catherine. I'm going to try to share my screen.
Let me turn
here.
things over to you. I will pause my sharing and we can get you started.
Excellent. Yeah, thank you so much. I appreciate the opportunity to present this morning. So I'm going to be talking with you about FLDigi for MCOM. What is FLDigi? Fast Light Digital, FLDigi is the main component of the narrowband emergency messaging software system. NBEMS, the narrowband emergency messaging software system, comprises Fast Light Digital, that's the main software package, Fast Light Messaging, Fast Light Amateur Multicast Protocol, FLAMP, and several other software packages. And I'm going to talk a bit about FLDigi and FLMsg this morning and touch briefly on FLAMP. These are the main software packages we use for emergency communications. I'll mention that FLDigi and the other software is available at w1hkj.com. You could literally download this software during my presentation and walk through it and get set up. And by the end of my presentation, you could have a functioning digital setup. So Fast Light Digital, this is the primary software we use. It sends and receives digital ham radio messages in a variety of modulations, in a variety of modes. FLDigi is used in combination with the other software. So you need to use FLDigi. That's the backbone that encodes and decodes digital transmissions. Fast Light Messaging combines with FLDigi, use it with FLDigi, and it allows you to send and receive formatted messages. For example, the ICS forms, an ICS 213 general message form, or an ICS 217 communications plan, for example. And then Fast Light Amateur Multicast Protocol, FLAMP, again, is combined with FLDigi. And what it allows you to do is to send and receive files in any format, and to send files individually or groups of files chunked into discrete blocks. And this facilitates sending information. And if for some reason there is an interruption, poor signal quality, for example, and some blocks don't go through, instead of having to resend the full file or the full message, you can isolate and send just discrete blocks of text, or discrete blocks rather of the files, and complete the missing blocks. So, as a amateur radio operator interested in emergency communications, why should you get on FLDigi? We operate oftentimes in conditions where the normal communication infrastructure, notably the internet, isn't available. And FLDigi is highly efficient at sending messages that would be very time consuming to try to send and to transcribe via voice. For example, again, like a communications plan, a list of frequencies or channels that we're going to operate on, or a set of assignments, for example. These are things that can be transmitted via text very efficiently, and are very cumbersome and error prone when we try to transmit them by voice. In addition, where FLDigi shines is it allows for one-to-many transmissions. So essentially a single transmitting station can send a message, and virtually an infinite number of stations can receive that message simultaneously. Whoever is in the receive zone that receives a strong, an adequate signal from that sending station. FLDigi, we'll talk a little bit about some of the different modes, some of the different digital modulations that FLDigi uses. FLDigi has a variety of modulations, and these modes are suited to different conditions. Some are a bit slower, but highly resilient or robust to poor signal conditions. Others can be quite fast, but are more sensitive to poor signal conditions. And you can use different modes to suit the conditions you're operating in. And as I mentioned, FLDigi combined with FLAMP allows you to send a variety of file formats and selectively correct for that missing data. And one of the great advantages of FLAMP is a third party, another receiving station, for example, can have received missing information, and they can actually relay that information to another station who's missing blocks. All of those are things that are possible with FLDigi in that associated software, FLAMP and FLMsg. In addition, FLDigi is actually very simple. It's a pretty simple setup. You can get on the air with FLDigi with a computer and your handy talkie. And FLDigi can be operated on a Windows machine. That's what I use. It will also work with Mac operating system and Linux. And digital modes are it's a pretty cool, like a lot of things that we get into in amateur radio. It's just a lot of fun. I'm going to go through several things in this presentation. What I'd like to do is for the ham radio operator who either has never gotten on FLDigi or has tried and is perhaps a bit intimidated, I'd like to go through just some basic setup and orient you to the operation of FLDigi, how to configure FLDigi or set it up properly, and then go through the basic send and receive. And I'm going to talk with you about audio coupling and setting up a very simple receive-only station with a basic audio cable to an HT, and then I'll briefly discuss some common modes, and hopefully we'll have some time for question and answer. I'll briefly also recommend that for those who are interested, there's really fantastic information in the FLDigi Beginner's Guide. It's a bit of a dense document, but there's fantastic information there. That's also available on that website, w1hkj.com. And then as Tim mentioned, in the Seattle area, we have the Puget Sound Digital Hamsnet. There's some information about our schedule and some resources on our website, psdhn.org. So what you need to set up an FLDigi digital station is pretty straightforward. It's pretty basic. You need a complete radio system, but as I mentioned, that can be as simple as a handy talkie. So you need, and again, I'm primarily working with VHF, UHF. This will also work with HF. You'll need a computer. I operate on a Windows machine, but again, you can use Linux, iOS. Ideally, what you want is an interface between your computer and the radio that will operate the push to talk. That's the optimal operating system. There is the SignalLink USB. That's an external sound card that's very popular. That's what I happen to use. There are some other interfaces. Master Communications has a DRA cable and external device to link radios to computers. Some radios also come with built-in sound cards. Ideally, you'd have those, and then of course the software, which can all be downloaded. It's free, and again, it's designed for this purpose. As I mentioned, really the only things that you absolutely have to have are the radio and the computer with the software installed. With audio coupling, you can literally hold the radio speaker up to the microphone of your computer and decode an incoming message. And conversely, you can actually transmit by holding your radio microphone up to the computer speaker and hold down the push to talk while you hit the transmit button on FLDigi. We'll get into that in a little bit. So a quick orientation to the FLDigi screening controls, because I find that this is actually one of the things that's intimidating. The FLDigi screen opens up, you open it up, and it can be a bit difficult to make sense of and to know where to start. So first off, this yellow screen at the top is your receive screen. This is where received messages will come in, and you'll see a cascade of messages come down. As the message is received and decoded, it will appear in that screen. FLDigi will try to decode any incoming audio. So if the squelch, which I'll talk about in a second, if the squelch in FLDigi is off, you'll see just a waterfall essentially of random text coming in gibberish. The blue window is your transmit window. You can type simple text messages in there and then hit transmit, and it will go out to receiving stations. In certain digital modes, multi-shift frequency keying, multi-frequency shift keying, 128, you can actually use that transmit window to load pictures and send images or pictures. Excuse me. Here is the waterfall display. It's always centered on 1500 hertz, but the bandwidth of that received, where it's receiving the signal, will change depending on the digital mode that you're using. And again, we'll talk about that in a second. But it automatically changes. You don't have to adjust that, but you do want to keep it centered on 1500 hertz. Incoming audio signals will be indicated, the strength of incoming audio signals will be indicated in this little column here. There's a green bar that rises and lowers with the strength of the incoming signal. The higher the bar, the stronger the signal. And then adjacent to it and below it is the squelch for FLDigi. So FLDigi has a separate squelch. That dark gray column adjusts the squelch level, and that little button you manually adjust up and down to raise the squelch. When you raise that gray button above the adjacent green bar of the incoming signal strength, it squelches the incoming signal. And the toggle, the SQL, the squelch button below it, toggles squelch on and off. And this is useful because you can set the squelch again to eliminate that incoming gibberish. So the FLDigi will be trying to decode any incoming audio signal. You can turn on the squelch just to keep random text from appearing on the screen. But for some modes, some of the faster modes, phase shift keying, in particular, we want the squelch completely turned off because of the to have as much of the incoming audio as possible. In the upper left-hand corner is a drop-down menu where you select the operation mode. This is the type of modulation. There are 17 different primary digital modes. So for example, one of the common ones we use is multi-tone 63 or MT63. That's the primary mode. So again, there's 17 different primary modes that you can select from. And then each of those primary modes has numerous sub-modes. So for example, MT63, there's 2000 kilohertz, there's 1000 kilohertz. This is the bandwidth. And there are different kinds of error correction, something called interleaving. There's long interleaving, that's the L designation. There's short interleaving, that's the S designation. So there are numerous modes and then submodes that you can select from. And again, we'll talk just briefly about some of the common modes. But you can select them from that drop-down menu. And then in the lower left-hand corner, you can see that little window that will show you what the current selected mode is. So in this case, we're in multi-frequency shift keying 64L. When you left-click on that mode, the main mode, it'll pop up a little menu and you can select the sub mode. This makes it very convenient. For example, sometimes we'll shift a mode to use less bandwidth if conditions are not favorable. And you can do that very quickly just by left clicking on that on the mode. And then if you right click, it leads you to the configuration screen for that mode. And there are a bunch of options that are way beyond my technical capabilities about the duration of tones and things. Excuse me. And then adjacent to the mode window on the lower left-hand side, it's currently blank, but there's a window where you'll see the signal to noise ratio of the incoming signal, which again can be helpful as you're working with fellow hams to diagnose problems. You'll just learn through experience what an incoming signal, feasible signal strength is. Just above it, there's a button that says WF. This is for waterfall, and that button will toggle your waterfall display through three different displays. The waterfall is the normal one. There's also a fast Fourier transform spectrum analyzer and a signal oscilloscope, and you can just toggle through the three. And then just adjacent to that, there's a number that adjusts the waterfall display's upper level and signal range. This just affects the display. It does not affect the received or sent signal. And then just adjacent to that, the ×1 button, that will adjust the scale of the waterfall display, zooming it in. So ×2 zooms the waterfall display in and just allows you to see more or less of the waterfall spectrum, of the incoming spectrum. Again, it doesn't affect your sent or received signal. The black arrows move the waterfall display left to right, again, just for viewing purposes. And then the black button will center the waterfall display back on the received frequency. And then the button that says norm, that will cycle the waterfall through different speeds. You can speed up the waterfall, the rate at which the waterfall display falls. You can pause it and you can make it slower. And again, this can be useful as you're trying to troubleshoot, as you gain experience, as you're trying to troubleshoot issues with incoming signals. One thing that confuses people is all of the buttons at the top, and particularly the frequency display. This is unnecessary for most purposes. If you use the computer, you can set up FLDigi to actually control your radio if the radios have computer control capabilities. But the displayed frequency otherwise doesn't affect FLDigi operation. So you can essentially just ignore most of that stuff at the top.
Hey, Christian, I'm going to jump in for just a second.
Yes, please.
We had a comment in the comments on YouTube about your window of your video is blocking some of the slide view. So why don't we try, if you don't mind, can you turn off your video while you narrate? I think that might help with that.
Absolutely.
Awesome. Thank you so much. This is great.
My pleasure. Thank you for that, Tim. So in terms of basic setup, so you've downloaded FLDigi and didn't want to get started. There are actually just a few settings that you need to go through in order to get FLDigi functioning. So at the top, there are a couple of buttons: RXID, receive ID, and TXID, transmit ID. These buttons are green when they're enabled, and you want to enable both of them. What they do is the TXID generates an identifier at the beginning of your transmissions that allows other stations, tells other stations what mode you're going to be using. And if they have RXID enabled on their FLDigi, it'll automatically switch them over to mode. So instead of going up to the op mode drop-down menu and again navigating through these 17 primary modes and a multitude of submodes, it'll just change over automatically for you. Again, one of the big things, that center frequency, it needs to be on 1500 kilohertz. One of the frustrating things about FLDigi is if you click on, the waterfall display in FLDigi, it'll actually move the center frequency, which can really distort the audio that you're sending and receiving, and make it difficult for you to send and receive effectively. After you make sure that it's centered on 1500 kilohertz, there's the LK button that locks center frequency. Although I'm not certain about this. I haven't systematically tested it. I believe that I have had it locked and have had center frequency change on me, but in principle, center it on 1500 hertz and then click that lock button and it should lock it in. The -3 number down here, this is the transmit level attenuator. And actually with digital signals, we don't want the audio to be too hot. It's something that we often do when we're new to digital modes is there are a number of places where we can increase or decrease the, both on the radio and FLDigi, increase and decrease the audio strength. And we tend to overdo it. We tend to have audio that's too hot. And what you probably want to start the audio transmit level attenuator at about -1 to -1.5, and then adjust based on your results. That's something that we can help you with on the Puget Sound Digital Hams Net. It's exactly the type of thing that we help the hams do. Just adjacent to that is the automatic frequency control, AFC. This will adjust the center frequency to the incoming signal, trying to match it up. I believe that that's useful on HF. On UHF and VHF, we don't want it to do that. It will overcorrect and end up getting us off of center frequency. So make sure that that AFC button is disabled. So next we'll go to the configure menu. And again, there's just a few settings on the configure menu that we need to go through. When you open up the configure menu, this is what it looks like. It has these expandable submenus, and you're going to go to the IDs submenu. You expand that and then go to RSID. And there's this setting in here, the pre-signal tone. And on the Puget Sound Digital Hams Net, we generally recommend that you set this to 2 seconds. And what this does is ensure that there's sufficient time at the beginning of your message for you to send message header information before you actually start sending the message body. Then next, if you go to sound card, this is where you indicate where the incoming and outgoing signals, what port on that computer they're going to. You want to make sure that that port audio button is enabled, is checked. And then the capture and playback, capture will go to your incoming signal and playback goes to your outgoing signal. So for me, I'm using a Signal Link USB. Maybe this is a product made by Tigertronics. I have no affiliation with. And for the Signal Link, almost invariably, these will show up as USB audio codec somewhere in the name. Typically, it looks like this: line, open parentheses, USB audio codec, close parentheses. If you're using audio coupling, where you're just using your computer, microphone, and speaker to receive and transmit messages, you just want you again want port audio selected, but you want these to show your computer, microphone, and speaker. So for me, when I do audio coupling on my laptop, this will show microphone, open parenthesis, Realtek audio mic input, and the playback will show speakers, open parenthesis, Realtek audio input, output, close parentheses. And after you make sure that those are set, you hit save. It's useful to have your call sign, enter your call sign under miscellaneous, and under there's operator station. You enter your call sign in a throwback to the old days of ham radio. There's a separate space for station and operator call sign. This other information isn't necessary. You can operate FLDigi without entering this, your location, your antenna, etc. This is just useful because FLDigi has built-in macro buttons that allow you to just automatically, with a push of a button, send certain information about yourself and your station. And if you want to do that, it's efficient to send information, for example, about the antenna you're using or your location. You can enter that information here, and then it'll go to macros. I'm not going to get into the macros, but if you're interested in those, please follow up with me later. And then when you're done, again, you click save on every window that you make changes to, and at the end you click close and close out of it. One thing to note, you may need to change the system sound settings on your computer, and there are a couple of things. One, you want to make sure that the audio input and output on the computer system settings, so like Windows has computer sound settings. For FLDigi, you want to make sure that those are set to your radio sound card. So again, for me, that's a signal link. It would be called USB audio codec or something similar. It's really useful to go into those settings. And again, this is where I can only speak for Windows, not Mac or Linux, but you can specify different audio devices for different apps. And what we advise in the Puget Sound Digital Hamsnet for Windows operators is to go in there and set to specify the computer, the radio sound card signal link just for FLDigi, and other sounds like the computer system sounds or any audio video playback sounds, to designate those to your computer speaker. And the reason is when you have a sound card set up on your computer, anything that you play on your computer will go out over the radio unless you have set the Windows sound settings to send all audio other than FLDigi to your computer speaker. So you could avoid the problem by not having any other applications open when you're doing digital radio, just making sure that you don't have any other applications open that'll send sounds. But it's as a fail-safe, it's really good to just make those adjustments. And again, if you have any trouble with that and want more information, join us on the Puget Sound Digital Hamsnet or reach out to me. And again, with audio coupling, this actually won't be an issue. So it can also be helpful. This isn't necessary to operate FLDigi, but as I mentioned, FLAMP, Fast Light Amateur Multicast Protocol, and FLMsg, Fast Light Messaging, those are actually separate software packages. They work in conjunction with FLDigi, but they're separate software packages. It can be really helpful to have those open automatically when you open FLDigi, and conveniently there's this way to do it. If you go back to your configure window, the configure menu, and go down to miscellaneous and auto start, you have these locations where you can automatically open related software. So there's a space for FLAMP, and what you have to do is go in and locate it. You click on the locate button, and then you navigate through the systems window to the location of the FLAMP software. Typically, that's going to be under program files in Windows, under program files x86, and then you'll see the FLAMP folder. The version changes. So this happened to be 2.2.05. And you want to make sure that the checkbox next to it is enabled. And again, for this may be different for Apple, for Mac and Linux users. We've got folks on the Puget Sound Digital Hamsnet who can help you with that. So please reach out to us if you're a Mac or Linux user. There are these separate windows for additional program files. I don't know why FLMsg is not one of the four at the top, one of the four predetermined NBEMS software packages that are set up for auto start. You've got to use one of these optional program auto start openings. But again, you do exactly the same thing as for FLAMP. You just you click locate, you navigate to the location of the program, make sure that that box next to it, enable is checked. And then the test button next to it, you can hit, and that'll just open the software. So you can make sure that it actually has navigated to the right place. And again, when you're done, make sure to click save before you close it out. And that's it for essential settings. At this point, you can actually send and receive digital modes with your computer and radio. So the basics of send and receive. So this is what an incoming FL message looks like. Again, the message will just populate as it's being received, going down. This is a formatted FL message that's coming in, and I'm going to show you the formatting in a moment, but this is what it looks like unformatted. So I'm receiving a formatted message that will format an FL message, but this is the unformatted receive window. This is what it looks like. This blue text at the top is that incoming mode identification information that I mentioned. This is what we get when we enable, this is what we send out rather when we enable transmit ID. And this is what enabling RxID allows FLDigi to recognize and then automatically change the mode. One thing that's a bit confusing, you'll see that there's a date timestamp, and then there's a mode MT63 2000L. This is actually the previous mode. This will confuse folks sometimes because as you'll see, the mode that I actually received this message in was different, but that's the previous mode. Don't get confused by that. This random text here, this is FLDigi trying to decode just some static. FLDigi will try to decode any incoming audio signal. You'll be shocked to learn that start actually indicates the start of the message. So we've got this little start indicator. This is some message header information. This includes the call sign of the station that was sending it. In this case, it was Ron, WR70N, who's a frequent participant in our Puget Sound Digital Hams net. There's the message subject line, weather on Saturn, and there's a timestamp. In this case, there are two timestamps. There's a timestamp, the first one, WR70N 2021-1603. That's the timestamp that the message was sent. This is actually a message that Ron had previously made and was resending. He'd sent it years earlier and was just testing. He was looking for a test message. So you can see right below, there's our WR70N 2016-2911. That was the date that he originally created the message. This is the incoming message text with an average temperature of minus 288 degrees Fahrenheit. That's the message. And then at the end, we have a checksum indicator. FLMsg has a checksum to alert you to errors. It actually will automatically pop up a message if there's a problem. And then the message concludes with an end of message indicator. So this is what the FLMsg window looks like. This is again, the program that'll automatically start up if you've set that up like we just went through with FLDigi. And when that incoming message comes in, it'll automatically populate into FLMsg. Then you can see that all of the information that we just saw unformatted in the FLDigi window is right here. It's just that it's in these separate formatted fields. Down here, it'll show us the mode, the digital mode that this was sent in this case, multiple frequency shift keying 128. And then it also shows us the message size and the transmit time, how long it took to transmit the message. FLMsg has a list of received messages. The default typically is for this to pop up automatically. And again, it's a setting that I won't go into, but if you need help with it, please reach out. But typically this will automatically pop up and you'll just get a list of all of the messages that you've received since opening up FLMsg. And when you select one of these, you highlight it. So like in this case, the message weather on Saturn from Ron is highlighted. And then you click view. It'll also open up the message in an HTML viewer, typically your web browser. And it's this nice, clean formatted message. which is extremely helpful for non-FLDigi users. Even the FLMsg window can be initially somewhat difficult to navigate. So for hams or non-hams, non-digital hams or non-hams, these HTML formatted messages are just really easy to read. And then they're also printer friendly. So in the event of a disaster, if we were printing out messages with instructions, it's really convenient having it in this nice formatted form. In terms of sending, simple messages, again, can just be typed directly into the blue text window. There's not a space limit. You just type in there. And then to transmit, there's this rather dangerous, innocuous button, T/R, that toggles FLDigi between transmit and receive. And I say it's dangerous because it is innocuous. It doesn't look like, there's nothing flashing to say, if you depress this, you're going to transmit. But when you click on that, it'll start transmitting, and it'll transmit whatever is entered into that blue screen, and it'll continue transmitting a carrier until you toggle the T/R button off back to receive. So receive is the default mode, of course. That T/R button is red when it's transmitting, it's green when it's receiving a signal, and it's blank when it's in receive mode, but it's not receiving anything. And again, by default, FLDigi is in receive mode, just like your radio. You can also use keyboard commands to transmit and receive. Control T will start a transmission. Escape will terminate a transmission. Although, just a heads up, I was confused by this initially. When I first, one of the first times I was using FLDigi and hit escape, and it didn't stop transmitting. For certain modes, it'll continue to transmit a post-amble, multi-frequency shift keying, phase shift keying, PSK are two modes that will do this. If you click escape multiple times in quick succession, escape, it'll terminate a transmission immediately, including the post-amble. And then a very useful function, a Control R typed at the end of a message will automatically return to the receive mode once the text message is sent. And again, just be aware that even if you don't have anything in that transmit window, if you click on the transmit button, the transmit toggle button, it will transmit. It'll just send idle characters. So I mentioned audio coupling. So you don't need a signal link or master communications DRA device in order to send audio and to receive digital messages or send simple messages. So you can do audio coupling to send and receive. You can also set up a basic receive only station with a simple stereo audio cable, or not even stereo audio, just a simple audio cable. And I'll go through that in a second. So for audio coupling to receive, you hold the speaker of your radio up to your computer microphone while the station is while the sending station is transmitting a message that you want to receive. You'll need to adjust the radio volume depending on how sensitive your computer microphone is. I will note that I have had FLDigi running on a laptop just adjacent to my radio, and have decoded digital messages just by accident by having my computer next to my radio. To send, you hold your radio microphone up to the computer speaker and press and hold the push to talk button while transmitting on FLDigi. Just make sure to keep the push to talk depressed the whole time during the whole transmission. Audio coupling will work with slower robust modes like MT63 2KL, the MT63 varieties, and a mode called Thor 100. It won't work with faster modes, quadrature PSK and 8 PSK. These are just less robust to poor audio conditions. Like I mentioned, you can also set up a basic receive station just with an HT. Most of us, many of us perhaps, I should say, have a Baofeng handy talkie dual band radio. And these make it particularly easy because they have separate audio input and output jacks. The Kenwoods likewise have these separate jacks for audio input and output. It just makes it really easy. So all you need is a 3.5 millimeter audio cable to the computer. And then the Baofeng uses a 2.5 millimeter audio input jack. So you need a cable that has a 2.5 to a 3.5 millimeter cable or an adapter. So the audio input goes on the 2.5 millimeter audio input. It's the upper jack on the Baofeng. You can see I just used a 3.5 millimeter cable with an adapter. You can also, if your computer, like my laptop, doesn't have an audio input, you can get a very cheap USB dongle that has audio input and output. And then most desktops will have a separate 3.5 millimeter audio input jack. As with audio coupling, you need to change the sound card settings in FLDigi to make sure that it's receiving audio from the computer microphone. So go to configure sound card devices, just like what we walked through before, and make sure that the port audio button is enabled, is selected, and that your capture is set to whatever that computer microphone is. And again, like if you're using a USB audio adapter like the one I showed, it'll typically say something like USB audio. I'll just briefly note the reason why this won't work for transmit. This will only work for receive, is because you could, in principle, set up a separate audio cable to go to transmit, but there's no push to talk capability. So you need something that will toggle the push to talk on and off, which is one of the key functions of the USB, the signal link USB, or the master communications DRA. So that's all it takes to set up the listen only station. I'll also note that FLDigi, there's an app for Android. There's currently not one for iOS, but there is one for Android. I've not used it. It's available at that same webpage, W1HKJ, but I understand that it works quite well. And you can, again, just set it up next to your radio and receive incoming signals. I'm going to jump through the modes really quickly, just in case we have any questions. But I do want to point out, this is another thing that can be intimidating for folks, because again, there's 17 different digital modes, plus dozens of subvariants. So it can be confusing. What should you be using? For MCOM, we often use MT63, and specifically MT63 2000L or 2KL, 2000L, 2KL. This is MT63 stands for multi-tone 63. It actually, I'm not sure why it's called 63 and not 64. MT63 encodes each character over 64 tones. And then it also encodes each character over a duration of time. So it's redundant via time and tone. And this makes it very robust for poor conditions, and it's still relatively fast. So the MT63 2KL is a very common mode and subvariant that we use, and 1KL or 500L are also common. I had mentioned the PSK phase shift keying modes. These encode digital transmissions at different points in the phase cycle. PSK is actually binary PSK. It uses 2 points in the phase cycle to encode messages. QPSK or quadrature PSK encodes over 4 points in the phase cycle, and then 8 PSK, as you might imagine, encodes it over 8 positions in the phase cycle. Each time you double that the number of positions in the phase cycle you're using, the more information you can send, but the more susceptible it is to noise. The harder it is to distinguish between those phase cycle positions. But the PSK modes are very, very fast, relatively speaking. Not compared to your internet, but for ham radio, they're very, very fast. I had mentioned MFSK, multi-frequency shift keying. I'll just briefly note that this is the only mode I believe that in FLDigi that can send images and so it's very useful for that reason. Olivia 8500, 16500, we hardly ever use in UHF, VHF, but I understand that in HF, it can be very useful because it's extremely robust. It can decode messages that you cannot hear several decibels below the noise floor. And then Thor 100 is a relatively newer mode. And I'll just point out, it also is, in my experience, has been highly robust. And it's almost twice as fast as MT63 2KL, Thor 100 is, but still seems robust in poor conditions. So it seems like a really good mode. So those are some of the common modes we use. Again, the Puget Sound Digital Hams Net, we meet Mondays at 8 p.m. We switch between two repeaters, the Columbia Tower repeater, WW7SEA, and the SeaTac Tiger Mountain repeater. I don't remember the call off the top of my head, but if you go to our website, Puget Sound Digital Hamsnet, psdhn.org. You can get our schedule there. There are a couple of nets for HF, the Orca Digital Net on Tuesday evenings and the Western Digital Net on Thursdays. I have not participated in these, but one of our regulars on the Puget Sound Digital Hamsnet, Mark, W7EAZ, highly recommends these, and the websites are here, so you can check them out. And then Mark had also pointed us to this excellent wiki, SIGID wiki. It's a signal identification wiki that has descriptions of digital modes. And one of the things that I like is that it's got images of the water file profiles of the different modes and then audio snippets, so you can actually play them and hear what they sound like. So that's it, Tim and Catherine. Thank you so much. I really appreciate the opportunity to join you, and I'll see if there are any questions or sign off for the next presenter.
Well, super, Christian. Thank you so much. And what a great presentation. And, FLDigi and the associated suite are really heavily used by us in this area. One of the things I want to mention, by the way, for folks who are not local to the Puget Sound area and therefore may think, well, how the heck can we be involved in this? The repeaters that we use, if you are an Echolink user, some of the repeaters that we use are available over Echolink or All-Star. So that's something to look up, because you may be able to at least listen in along, even if you aren't able to send and receive messages. And I've often, even just driving around in the car, I've listened to this net, because there's so much great back and forth between net control and the folks who are sending and receiving and practicing. It's really a great teaching resource, and you hear the net control folks helping people along and giving kind of live tech support on that. So if you are not in the Seattle area, don't worry, there may be a way for you to sort of play along. And I'll also mention there are some articles on the PSDHN org website as well. And I imagine, I don't want to put you on the spot, but I'm guessing that article library will probably grow over time. So that's another way that this resource can help folks who may not be in this area. But really great stuff. I had been using this with MT63 2KL for a long time, and I've been slow in picking up some of the other modes, and I bet I'm not the only one out there. So it's really cool to learn a little more and get a little more familiarity.
Thanks so much.
Christian, we had a couple questions in the chat. There were a lot of questions around actually for backup power for laptops. Can you talk a little bit about like the basic entry point equipment that you would recommend for either new hams or even non-hams who just want to be able to monitor?
Yeah, and actually, Catherine, that's a great point. That in fact, to receive digital transmissions, in fact, you don't even have to be a ham, right? You can. There's nothing to keep people from receiving digital transmissions. In terms of the entry point for the purchasing a USB Tigertronic SignalLink USB, those are about $130, I believe, and they'll come with a radio cable. They do require some configuring, but I found it. I'm not a particularly technical person, and I did find it feasible for me to do. And again, that's exactly the type of thing that we're happy to help steer people through with the digital Hamsnet. And then the master communications. is a device that I don't have experience with. It's a newer device. It actually has some advantages over the SignaLink USB in terms of the audio that it's able to transmit. And I believe that the cost there is under $100 for the device. And then you need a radio cable, the cable to connect it. I'm not as familiar, but I believe that you can get into that for less than $100. And as Tim mentioned, this is the type of information we're going to try to be adding to the web page, the Puget Sound Digital Hamsnet web page.
Awesome. Well, we've got a couple more questions. And, for folks who asked a question, if we're not able to get to your question live, we may be able to jump into the chat and answer it in the chat. And so let me see if there's a couple others that I can answer or ask. Ted asked, in a major earthquake scenario, when all power and comms like phone and internet are down, how does the system work in a backup comms mode? And I think that's ultimately the beauty of this, right, is how decoupled it is from all of those systems, like entirely independent.
Yeah, and that is, I didn't have time to get into it. There, one of the things that we use is also WinLink. WinLink offers ham radio email, but it also depends. There is a peer-to-peer mode, but it depends on an infrastructure on a node backbone. And FLDigi, just like you said, Tim, is really it is a radio to radio. And assuming that you've got we're assuming that you're operating a radio, and therefore you have some kind of electric power backup, batteries, solar or something, and a laptop, you're going to be able to operate on that. And one of the things that is really exciting with the apps is this ability, I mentioned the Android app, is the ability for really anyone to have a radio and to have a phone, really a low power, use phone right there, and to be able to receive and decode a message about critical information around a disaster. Yeah.